So following on from the previous video, we got to this stage here. Bear with me. We got to this stage here. We got to this stage here. So now if you tidy this up, so basically you've got something here. Take away another thing. You can remove the brackets and tidy everything up. Remove the brackets. It will then give you this, and then tidy this up. And the whole thing here. Tidy up and then factor out the 2. We'll cancel out the tidy it up, and then it will then give you this thing here. And then now push the square root in here, because at the moment you've got square root of b over a, so that's the same as square root of b over square root of a. The square root of b becomes this thing here, nice and simple, because you've got this squared here. And then push the square. So this thing here will then become this thing here, and then now. So when you get to this stage here, substitute this. So let's u be cos t over 2. So later on we can make this to be u squared, and then make this substitution. Let u equals this thing. If u equals this thing, then du equals this thing, and then dt equals this thing here. So we can now put this into the dt here. So this thing here will later gets cancelled out with this thing here, and then because we made u equals that, we can later this will then become u squared, and then this t. Remember, t0 is just a constant. Is just a constant. So let's see be this. So now we can put this into here. At the moment it's squared, so this here will be c squared. Okay, so make this substitution and then make this substitution. Then this whole thing here will then become this. So now this here is a constant. We can take it out here. So hopefully you should be able to recognize this. How would you integrate this? So hopefully you could recognize it. But remember, hang on. So remember, this here is a constant. We're going to take it out here, so it becomes -2, and then this here is 1. So when you get to this stage here, hopefully you can remember how you integrate this. And also remember that we made the substitution here. By right, we should change this, but leave it as t equals t0 and t equals pi, because later on we're going to switch u back into t again. So for the time being, just leave it as t equals this and t equals this. Hang on. So let's go back one step here. We take this out, so that then becomes -2, and this becomes 1. So now hopefully you can recognize how you should integrate this. So remember, if you differentiate arc sine of ax, it will then give you this. So this is very similar to this, very similar, but not quite. So you should have seen this before. If you differentiate this, it will then give you this. But what happens if you try and differentiate inverse sine of 1 over, so suppose so here you've got a constant here. Suppose the constant is 1 over a. If you differentiate this, it will give you this. Hang on. So we are trying to differentiate this and see what happens. When you differentiate this, it will give you this. Blah blah blah. And you should know how to differentiate this by heart. So if you differentiate it, it will then give you this. You see, this thing here is very similar to what we were trying to do. So earlier we were here. Remember, we took the -2 out, so that will then give us this. So it's just a matter of integrating this. Now if you look at this here, we are trying to integrate this. But if you try to differentiate inverse sine of x over a, it will then give you this thing here. And this thing here is very similar to this. So when you try and integrate this, it should give you something along this line here. Okay, well, integrate this, and it will give you inverse sine u over c. Okay, and remember, okay. If you integrate this, it will then give you this. Okay, and now we need to change. So our answer now is in terms of u. We need to change the u back into the t. So remember, our substitution earlier was u equals this thing, c equals this thing. So now we can put this thing back into the u, and then put this thing back into the c. That will then give us this. So it's one thing divided by another. So now we are evaluating it from we are evaluating it from well, now you've got to put pi into here. Remember, this is a constant. Okay, t0 is a constant. So the first thing would be put this into here. So cos of pi over 2 is 0. So if this thing here is 0, then you're going to divide by, don't forget t0 is a constant. You cos that weird number there. But the point is that if this is 0, then the whole thing here will be 0. So sine of 0. So this whole thing here will be sine of 0. So hang on. If you put pi into here, then this thing here will then become this. So now put t0 into here. So t0 into here. Notice that this thing here is exactly the same as this. So it must be. So this thing here must be 1. It must be 1 here. So we've got to take away inverse sine of 1. So hang on, one step back. Put this into here. Then this whole thing here will then become this. Now put this into here. Then you've got exactly the same divided by exactly the same. That will then give you this 1 here. So from here, that will then take us to here. So now you've got to ask yourself, you've got to ask yourself, what is inverse sine of 0? So inverse sine of 0 will be 0. Inverse sine of 1, well, 1 is here. So this will be pi over 2. Well, this thing here will then become this. So overall, the answer will be this. Okay, so no matter where you place t0, the total time that it takes to get to the very bottom will be given by this. The reason why t0 doesn't matter is because when you look at this here, no matter where you place t0, when you put it into here, this will give you t0. So this thing here will be exactly the same as this. So looking at this here, it doesn't matter where you make t0. If you put t0 into here, then this is going to be exactly the same. That's why it doesn't matter where you place the particle. It doesn't matter where you make t0. T0. It doesn't matter where. Well, it doesn't matter what t0 is. It's going to give you exactly the same divided by exactly the same. So well, anyway, overall the answer will be this. Okay.